Yes. Okay, so forces in nature, part 1. So, reminder, force of gravity, F sub g, is force of gravity. Now, that is a unit of newtons, like any other force. Now, the formula for force of gravity is mg, where m is mass in kilograms, and g is acceleration due to gravity. And what is that number normally? Negative, or 9.81. Now, you're right. Sometimes we say negative, but if we say down, it means the same thing. So the minus sign gives us a direction. Remember that. Now, quite often in the calculations, we'll forget the minus sign, but it should be there. So far, so good? All right, now, several things to note here. First thing, mass is in kilograms, which is literally the number of atoms. You've all done atomic mass and molar mass. Carbon is 12.01 grams per mole. Oxygen is 16. Zeros, but at so many zeros you hit some number. Anyway, now, this is a definition question. Weight is force of gravity. Newtons. So, if I talk about weight, it's different than mass. So guess what? You're going to get a multiple choice question on the test. Definition, you have to know this. All right? What's the difference? So, an example for you guys. Mr. S has a mass of 88 kilograms. What's his weight? What's the force of gravity acting on Mr. Sutton? Now, careful, that's acceleration. Weight is force of gravity, which is mg. So grab your calculator and tell me what mg is. What's m? I'm sorry. M is kilograms, and g is 9.81 meters per second squared. So what are we getting? Show me again. Yes. Now be careful. The negative is what? A direction. Do we have to include the negative here? No. No. So it's 88 kilograms times 9.81 meters per second squared, which is how much?
863.28.
863.28. Call it 863 newtons. That sucks. I definitely got to lose weight. All right. So far, so good? All right. This textbook is 11 newtons. What's the mass? Calculus. Woohoo. Painful math. Oh, you wait. Calculus. Derivatives. Integration. But it's so much fun.
Yes, if you call pulling your hair out and crying.
One strand at a time all night. Yeah. Oh, you've taken a math course with me before. All right. So, now, okay, let's work backwards. I'm asking, what's the mass here? Now, what formula have we been blathering on about? Come on. Actually, pull out your blue formula sheet. I think it is on your formula sheet, isn't it? Yes. Speaking of which, you owe me homework. Go get it. Run, boy. Run faster. Is it man or just from Doesn't
Okay.
this? You know, say no. Everybody wave to the camera. All right. Actually, it does. It has G is force of gravity over mass. Your formula sheet, oh, it's following me, good, has G is force of gravity over mass. Now, I want you to realize normally I write that force of gravity equals mass times acceleration due to gravity, whatever. You made it this far through the course, you can rearrange that equation for me. Now, I want to solve for mass. That's the one version of the formula I haven't given you. So if I rewrote this to solve for mass, what would it look like? Sorry, it would look like? Force of gravity divided by gravitational constant. Yes. So what's the force of gravity? No, hang on. The force of gravity is the force gravity is pulling it down with, which is 11 newtons. Acceleration due to gravity. Now, careful, guys. Acceleration due to gravity is G. There's force of gravity, F of G, and G, acceleration due to gravity. Don't mix those up. You're using them correctly in the equation, but you're mixing them up when you're talking about them, and that confuses me. What is G here? Now, you feel ready? Chapter 1? Chapter 2. Oh, finish it. Yes, of course. Sorry. I put it. Oh, sorry.